I am Ravi Kumar, Director, RK Physics Academy, located in Nalakunta, Hyderabad. I am taking physics classes for CAB Educational Services Limited. In my last class, I was explaining to you rotatory motion. So far, we have completed two phases of rotatory motion. So, the first phase consists of torque and again that parallax theorem, perpendicular theorem and moment of inertia. And we have completed that necessary theory and again after that problems also. Thereafter, we came to the second phase. So, in that second phase, it is angular momentum and conservation of angular momentum, and thereafter it is energies of a rolling body, and thereafter it is the velocity, time, acceleration of a rolling body along that inclined plane, at the bottom of that inclined plane. And we completed the theory and again the problems of that second phase also. And thereafter now we are coming to that last phase, that is the third phase, and it is nothing but rolling motion, types of rolling motion. So, types of rolling motion here, first of all we have to understand rolling motion is a combination of translatory and rotatory motion. Translatory and rotatory motion. So, here in case of this rolling motion, so the first one we are taking, it is a pure rolling. So, here it is a pure rolling. So, in this pure rolling, what we are taking, it is a combination of, as I already told you, it is a combination of a translatory and the rotatory motion. So, that is first of all we are taking only that rotatory motion. So, in this case rotatory motion, so first we are taking, this is the velocity of that v is equal to r omega, v center of mass can be taken, and thereafter it is also v center of mass, and here it will be the center. Now it is rotating like this. It is only that pure rotation. So, it is a pure rotation can be taken here like this. So, it is a pure rotation, velocity of that center of mass and again the v center of mass is here. So, it is in the pure rotation. Now, we are taking, here it is, when you are coming to the second case, in this second case, here it is all particles, it is nothing but the translatory motion. So, here it is all particles are having, that is translatory motion is defined as when a force is applied to a body, if all particles are having the same displacement, same velocity, same acceleration, then it is said to be the translatory motion. It is the simplest type of motion. So, that is why here in this case all particles are having the same velocity, v center of mass is here and this is also v center of mass, and thereafter it is the v center of mass is here like this. So, now it is a pure translatory motion. It is a pure translatory motion. So, next one when you are coming to this, that is a combination of both of them, that is a pure rotation and again the pure translation. So, now we are coming to this rolling motion, pure rolling. So, in case of this pure rolling, when you are coming to this bottom and again this is a top. So, now when you are coming to this bottom, so it is a combination of that is v center of mass and again the v center of mass. Here in this case v is equal to minus v center of mass, both are opposite to each other. So, that is why it can be taken, that is the velocity at the bottom can be taken as the 0. Velocity at the bottom can be taken as a 0. Next one. So, it is the minus v center of mass plus v center of mass. So, that is why the combination is becoming 0. Next after that, when you are coming to that at the center, it is a combination of 0 and again the v center of mass. So, that is why in case of the rolling motion v is equal to, that can be taken, v center of mass is here. Now, when you are coming to this at the top, so at the top it is a combination of both of these velocities, v center of mass and again the v center of mass. So, that is why v is equal to 2v center of mass. V is equal to 2v center of mass. So, that is why in case of pure rolling, it is a combination of both translational and again the rotational. Now, here at the bottom it is a combination of these two, that is why it is become 0. And again in case of that center of that rolling body, it is the 0 plus v center of mass, that is why the resultant becomes v is equal to v center of mass. And thereafter when you are coming to the top, so it becomes, it is v center of mass and again the v center of mass, finally it is becoming the 2v center of mass. That we can observe, even in that case of practically we can observe, suppose a circular ring is placed on a horizontal plank like this. So, horizontal table, something is a horizontal table is there, a circular ring is placed like this. And here we are placing finger, we are holding that ring by placing the finger at the bottom of this. At the bottom of the circular ring, we have placed the finger like this. Now, when a gentle push is given at the center of this circular ring, when a gentle push is given, when you are placing like this, when a gentle push is given, then we can observe the points which are in the contact points. The contact points almost there won't be any type of displacement or the velocity for the contact points with that horizontal plane. And again, when you are observing at the center, and there will be slight little displacement is there, and a slight velocity is also there. And when you are observing the top position, at the top position, definitely it's a velocity you can observe. It will be double to the top of the velocity at that center of mass. So that's why here it will be the 0, and here we consider it is the v, and here it will be the 2v. So this concept is used while you are solving the problems based on this pure rolling. Now, once again I will tell you. So, first of all, we are coming to the first type of that rolling motion. It is the pure rolling. In this case, pure rolling, what we can take, it is V center of mass is equal to R omega. That is the first characteristic of that pure rolling is V center of mass is equal to R omega. And the next characteristic is S is equal to 2 pi r in one revolution. These are the two characteristics followed by this pure rolling motion. So, V center of mass is equal to R omega and S is equal to 2 pi r is there. So, in this case, S is equal to 2 pi r in one rotation means, suppose when you have taken a sphere or that some wheel is there, and when you are taking one complete rotation to that wheel on that horizontal normal free road, on a horizontal normal free road, when you have given one complete rotation to that wheel, suppose if you are taking this point P and that point P comes here. So, now here the distance moved advanced by this wheel is like this in one complete rotation, and we can observe that a point P comes here like this, and thereafter it moves to this position here like this. It is 180 degrees, and again here it is a 180 degrees. So, that's why overall it becomes 2 pi r. The distance advanced by that wheel, the center of that wheel in one complete rotation is equal to 2 pi r. Then in that case it is said to be the pure rolling motion. It is said to be pure rolling motion. So, that's why we are coming to the, so far we have completed that pure rolling motion. Pure rolling motion is a combination of a pure rotation and again the pure translational. So, pure rotation means like this. So, it is rotating there only, just like a fan, it is rotating there only. So, it is V center of mass and again the minus V center of mass because it is in opposite direction, and thereafter it is a pure translational. All particles are having the same velocity, same displacement, same direction. So, that's why it is a pure translational, and the combination of these two, that is a pure rolling, that is a combination of these two, result is the 0. Combination of these two, result is V center of mass, and the combination of these two, result is the 2V center of mass, like this. And again here what we can understand in case of the pure rolling, that is if you, that is the velocity is 0 here at the point contact points, and here it is the V and here it is the 2V. Practically we can see that suppose a circular ring is there, it is placed on the horizontal table, and we place the finger on it, we are pressing it like this, and we have given gentle push to that ring. Then we can observe at that point of contact there won't be almost displacement of that points is the 0 contact point, that is the velocity is the 0. And if you observe this velocity, if you consider this velocity is the V, and immediately you can observe the velocity at the top position is the double to the top of this velocity. So, that's why it will be the 2V. Then you can call it is a pure rolling motion. So, in a pure rolling motion, V center of, these are the two characteristics. V center of mass is equal to R omega and S is equal to 2 pi r can be taken. Similarly, S is equal to 2 pi r. So, now here S is equal to 2 pi r means in one complete rotation. Suppose if you are taking a wheel and you have given a mark P is here, and if it is pushed like this and one complete rotation, the distance advanced by the center of this wheel will be equal to 2 pi r. So, then it is set to the pure rolling, and it is possible on a normal free horizontal road. That is the first case is over. So, now first type of rolling motion is completed. So, that is the pure rolling is completed. Now, we are coming to the second case, and that second case is nothing but a forward slipping. So, here it is a forward slipping in this case. So, it is a forward slipping, and here we are taking the type of rolling motion. In this case, V center of mass greater than R omega. V center of mass greater than R omega, and S greater than, that is the linear displacement travelled by that, and that is also greater than 2 pi r. S greater than 2 pi r. So that's why here these are the characteristics of that forward slipping. In these characteristics, V center of mass greater than r omega and again S greater than 2 pi r. So it is possible only, suppose if at all that rain is already over and the road is a completely free and smooth surface and it is a smooth surface and frictionless, almost friction is reduced here. And in that case, if you are pedaling a cycle, if you are driving on a cycle, then in that case, if the brakes are applied, then in that case, the linear displacement traveled by that center of that wheel will be more than that of r omega. So here V greater than r omega. V greater than r omega, its meaning is the forward movement of that wheel will be more than that of the rotation of that wheel, because here it is friction is slightly reduced there and it is already rain is over and the road is a completely free smooth surface. In that case, it is not the dry surface, it is smooth surface. When brakes are applied, the forward movement of the wheel will be more than that of the complete rotation in one rotation. So here in one rotation, actually if at all it is a normal free road, the distance moved by that wheel should be 2 pi r. But in this case, it travels a distance more than 2 pi r. So it is S greater than 2 pi r and finally comes to rest somewhere here. So finally comes to rest somewhere here like this. S greater than 2 pi r. So in this case, that is known to be the forward slipping. So while it is a forward slipping in this case, so now here the contact points rub the road in a forward direction. The contact points of that wheel with the road rub the road in a forward direction like this. That wheel pushes the road in a forward direction like this. And because of that reason, always the friction will be opposite to that of the applied force. Here the applied force is in a forward direction. It is applying the force in a forward direction like this. That's why in case of the forward slipping, the friction will be opposite to it. In case of that is forward slipping, the friction will be opposite to the motion of that wheel. So here V center of mass greater than r omega and S greater than 2 pi r, and it is possible after the rain is over and the road is completely smooth and slightly that friction is also reduced. And here we cannot take the case, and one more point, here we cannot take the case if hard brakes are applied, what happens? If at all hard brakes are applied, then instead of getting rotation, slight rotation, now it is completely slipping off the wheel. Now it becomes a completely slipping off the wheel. Then it will be taken as a sliding motion only, or the translatory motion of the only of this complete system of this body. It is a translatory motion only. But we should not take that case, because here we are here to discuss the types of rolling motion. So that's why here don't take that case. Once the hard brakes are applied, what happens to that wheel? You cannot take that case. Here the brakes are applied, but it is having that tendency of slipping also, and that slipping, because of that slipping, S greater than 2 pi r. That is known as forward slipping, because here the contact points are rubbing the road in a forward direction like this. So that's why friction will be opposite to it. So that is the second type is over. Now we are coming to the third type. Third type, in this case, now here what we have to take, V center of mass less than r omega. V center of mass less than r omega and S less than 2 pi r. So V center of mass less than r omega and again S less than 2 pi r. So here what we have to take, it is the distance advanced by that wheel will be less than 2 pi r. So in this case, what happens? So here it is possible, suppose if you are driving the bicycle, in a road which is completely lot of mud is present, it is completely wet soil. In that case, if you are rotating that wheel, if you are pedaling that wheel, then the distance advanced by that wheel will be less. It is not the complete, even though it is a complete rotation is there, the distance advanced by that wheel will not be equal to the 2 pi r. It is less than the 2 pi r, and but the rotations will take more. So that's why here V center of mass less than r omega and S less than 2 pi r. And that is possible when you are pedaling the cycle, when you are pedaling a cycle on a road which is a completely lot of mud is present and it is a completely wet soil like that. So in that case, when you are pedaling, the rotations will take place more, but the forward movement of this wheel will be less. So that is S less than 2 pi r is here, and in this case the wheel applies the pressure, the contact points applies the force in a backward direction. So applied force will be like this. Applied force will be like this. So in that case, when the force is applied like this, the frictional force will be in this direction, because so friction is always opposite to that of the applied force. So because of that reason, applied force will be and frictional force will be in this direction. So these are the three cases of the rolling motion. Here also we cannot take that case. Suppose if at all there is no any forward movement, and because of that soil, and if the wheel is rotating there only, we cannot take that case, because in that case the wheel will be having that pure rotation only. Pure rotation only. Here we have to discuss that rolling motion. So that's why this is the third type of rolling motion, in which forward movement is also there, and again the rotation is also there, but the forward movement comparatively is well less when compared to that of the rotations like this. So this is, in this case, applied force will be the contact points rub the road in a backward direction. So that is forward slipping is over, and again this is the backward. So now all these three cases are completed in rolling motion. The first one is pure rolling. It is a combination of both the pure translational and again the pure rotation. And the second one is a forward slipping, in which that is V center of mass greater than r omega and S greater than r 2 pi r. Next one is here in this case of backward. Here V center of mass less than r omega and S less than 2 pi r in complete rotation. So now normally on the free horizontal road we have to take the pure rolling only. So that's why what is that point that you have to remember, whether it is the pure rolling or not. So that is V center of mass is equal to r omega is given in any problem, then you have to understand it is a pure rolling. If at all that V center of mass is not equal to r omega, then you have to decide, you have to check whether it is coming under that forward or the backward. That you have to decide it later. Now we solve the problem, some problems based on this pure rolling motion.